You know that feeling. When you're diving into something new, maybe a topic, and you've just got articles, research, maybe even your own notes piling up, and you just want, like the really important stuff, fast, without feeling totally buried. Yeah, that's exactly why we started the deep dive. We basically take that whole stack of sources, all the articles, the research, your notes, and we pull out the absolute key nuggets of knowledge for you. Our mission is simple: give you a real shortcut to being well-informed minus the overwhelm. And maybe, toss in a few surprising facts to keep it interesting. So today we're embarking on a deep dive into a concept that's, well, it's pretty foundational if you're curious about how software works. Especially in Java, we're talking about lists. And if you're thinking, oh, code, that sounds way too technical, just hang on. I promise, you really don't need to be a coding whiz to get this. We're going to break it down using some real-world examples that I think will make it super clear.
Indeed, and the lists, they really are fundamental in programming, especially Java. Getting a solid grasp here gives you such a strong base for, well, for any more learning you might want to do later on. So in this deep dive, we'll explore what lists actually are, why they're so incredibly useful, how they actually work sort of under the hood, and we'll even share some practical tips if you're just starting out.
Okay, let's unpack this for you then. When we say a list in Java, what exactly is that? And maybe more importantly, why should we care if we're, just beginning to look into programming? Well, think about a simple to-do list, the kind you might scribble down for your day. You write tasks in order, right? Buy groceries, call mom, finish a report. Later, you might add something new, maybe cross one off when it's done, or even shuffle things if priorities change. That's essentially what a Java list does. It's like a special digital container designed to hold a group of items. Programmers call them objects. And objects, just think of them as pieces of data. Could be a number, a word, maybe something more complicated like, I don't know, a customer's entire profile. And they're all stored in a very specific controllable order.
Precisely. And just to give a bit more context, lists belong to a bigger thing in Java called the Java Collections Framework, or JCF. You can sort of picture the JCF as this big toolbox Java provides for handling groups of data and a list. It's one of the most versatile and frequently used tools in that box, perfect for keeping items nice and sequential. There are a few key things that really define what a list is. First, order matters. Big time. Unlike just, throwing items into a bag, items in a list stay in the exact order you put them in, like a numbered list in a notebook. Second, duplicates are allowed. Yeah, you can have the same thing multiple times, like writing buy milk twice if you need, say, whole milk and almond milk. Totally fine. And third, probably one of the most useful aspects, flexible size. Lists can grow or shrink automatically as you add or remove items. This dynamic part is super important because, let's face it, in real applications, data is almost never static. It changes constantly. Lists handle that change really elegantly without you having to manually resize things like you might with older ways of storing data.
Yeah, and the flexible size thing really clicked for me when I was reading through the sources. It's so much like a playlist in a music app, right? Spotify, maybe. The songs are in a specific order. You can add new ones. You can remove songs you're bored of. You can drag them around to reorder them instantly. A Java list works just like that. It holds those digital items, those songs, in a sequence that you control. So they have order. What does that immediately bring to mind for you?
So, okay, we've got a decent handle on what a list is, but the real magic, I think, comes when you understand why programmers reach for them so often. Why are they such a cornerstone? Well, they are genuinely one of the most popular tools in Java for managing groups of data. And it boils down to them being incredibly simple to use, but also immensely versatile. Think of it like that trusty notebook again. You jot things down in order, you can erase, add, change things whenever you need to. Simple, effective. The core purpose of using lists, well, it comes down to a few main points. First, obviously, they store ordered data. The sequence matters, it's preserved. Second, they allow for easy manipulation, adding, removing, changing items. It's generally straightforward without complex rules or needing to manually shift everything else around. Third, and this is key, they offer access by position. Every item has a specific spot, like a page number, right? We call it an index. This lets you grab or modify an item really quickly if you know its position. And finally, as we mentioned, they handle dynamic data. They grow, they shrink, no problem. Perfect for when you don't know exactly how much data you'll have, like tracking users logging into a website or items in an online shopping cart.
Right. And for you listening, especially if you're just starting out, the benefits are really clear. First off, their simplicity. They're generally quite intuitive, very beginner-friendly compared to some other data structures. Then there's the flexibility. They work for all sorts of data. Simple numbers, text strings, or even, like we said, complex objects. maybe a whole student record with name, ID, grades, everything. And because they keep that order, there's a real predictability. You put something in at position 3, you know it'll be at position 3 unless you move it. You always know where to look. Plus, for certain jobs, they offer great efficiency. Adding something to the end, super fast. Getting the item at a specific position, also generally very quick. Okay, this might sound almost too simple, but think about your everyday grocery shopping list again. You write items down, maybe in the order you plan to walk through the store. Apples, then bread, then milk. If you suddenly remember, oh, cheese, you can just scribble it on the end. Or maybe you want it near the milk, so you squeeze it in between bread and milk. And if you look in your cart and realize, wait, I already have apples, you just cross them off, remove them. A Java list lets you do all of this digitally managing items in a specific, flexible order really easily.
Exactly. And this flexibility you're highlighting, that's precisely why lists are just everywhere in programming. It's so rare for data in an application to just stay static. You've got user input coming in, database results flowing back, maybe real-time sensor data. It's always changing. Lists give you that crucial power to manage dynamic information effectively and, importantly, intuitively.
It's amazing how straightforward the concept feels on the surface, isn't it?
Yeah.
But like, how do they actually do all this? What's happening, under the hood to keep track of everything and maintain that specific order?
Yeah. Okay. Yeah. Good question. To understand how lists work internally, try picturing a row of lockers, like in a school hallway. Each locker has a number clearly painted on it, right? Each locker holds one thing, maybe a book, gym clothes, whatever. And you access what's inside, or you change it just by using that locker number. Lists in Java store data very much like that. Each item gets assigned a numerical position. We call that position an index. And the crucial detail here is the index always starts from 0. Always. So the very first item you put in, that's at index 0. The second item is at index 1, the third at index 2, and so on. It's a common source of small bugs for beginners, that zero-based indexing.
The classic off-by-one error source.
Exactly. So this brings us back nicely to those core features, but now think about them with the locker analogy. You've got indexed access. Every item has an index, 0, 1, 2. This lets you find or change items super fast, just like knowing which locker number to open. Then, dynamic size. Unlike a fixed bank of lockers, a list can magically add more lockers if needed, or remove empty ones. You don't run out of space, you don't have wasted empty slots. Ordered storage just means the items stay in the sequence you put them in, like lockers 1, 2, 3 staying in that order, unless you specifically move things around. And yes, duplicates allowed. You could, theoretically, put identical textbooks in locker 5 and locker 12. The list doesn't care, it just stores what you give it at the specified index.
Okay, the locker analogy helps. So how does it actually organize the data when things change? Like when you add a new item, you said it goes either at the end or you can put it somewhere specific.
That's right.
So if my list had, say, apple, banana, orange, indices 0, 1, 2, pram, and I wanted to insert grape right between apple and banana.
Yep, you tell the list insert grape at index 1.
And what happens then? Does banana just get overwritten?
No, that's the clever part. The list automatically shifts everything from index 1 onwards down by 1 position to make space. So banana would move to index 2, orange would move to index 3, and grape would slot neatly into index 1.
Wow, okay.
And the really amazing thing is the list manages all that shifting and updating of indices for you automatically. You don't have to write code to manually move every single item. The list abstraction handles that complexity.
That is pretty neat. Okay, here's another example that might help you visualize it. Organizing a line of people waiting for a concert. Each person has a spot in that line, right? That's their index. You can easily add a new person to the very end of the line. That's simple. Or maybe someone's friend is already third in line, and they let them cut in right there. That's like inserting it index 3. Everyone behind them has to shuffle back 1 spot. So one might get tired of waiting and leave the line that's removing an item. The line naturally closes up the gap. Or you could quickly check, hey, who's 5th in line? That's accessing by index. A Java list basically manages data just like that, keeping items ordered, letting you access them, add, remove, insert, all by their position. It's powerful because it mirrors how we intuitively think about ordered sequences.
Absolutely. And it's quite fascinating, isn't it, how that simple concept, just giving everything a number, an index, allows for such powerful and flexible data management in software, which naturally raises the question, what kind of common things can you do with these lists once you've got them set up? What are the typical actions?
Yeah, that's the perfect next step, right? Because Lists aren't just about storing things. They're powerful because they let you do stuff with the data. They support a whole range of actions or operations. Really, it's like all the things you'd naturally want to do with that physical to-do list we talked about earlier.
That's exactly right. Let's quickly run through some of the most common list operations. You've got adding items. You can stick things on the end or, like we discussed, insert them at a specific position, just like adding a new task anywhere on your paper list. Removing items. You can remove an item if you know its position, its index, or you can tell the list to remove a specific item itself, like remove by milk, like crossing off a completed task. Accessing items. This is just retrieving an item using its index, like checking what's the third task on my list. Updating items. This means replacing an item at a certain position with a new one. Maybe you change by milk to by juice at index 2 because you changed your mind. Checking size, simply finding out how many items are currently in the list, like counting how many tasks you have left. Searching. This is checking if a particular item exists anywhere in the list, like quickly scanning your list to see if Call Mom is already on there. Iterating. This just means going through each item in the list one by one, usually from start to finish, like reading all your tasks aloud. And finally, sorting. You can ask the ArrayList to rearrange its items based on some criteria, maybe alphabetically or numerically, like sorting your tasks by priority level.
Okay, so why do all these different operations matter so much? Well, they're what make lists so incredibly useful for tasks where both order and flexibility are really important. For example, think about a game keeping track of players' scores on a leaderboard. A list is perfect for this. It can store the scores in descending order. You can easily add a new score when a player finishes. You can remove a player if they quit the game. And you can instantly display, say, the top 3 scores just by looking at indices 0, 1, and 2, all without needing to manually reorganize everything constantly.
That's a great example. Or think about a movie theater's seating chart for a specific showing. Each seat has a number, right? And the chart needs to track who's sitting where, or if a seat is empty. You can assign a new customer to seat number 10, which might correspond to an index. You can remove clear seat number 5 if the person leaves mid-movie. You can access, quickly check who is supposed to be in seat number 3. You can update, maybe change the name associated with seat number 7 if there was a booking mix-up. And you can easily count, see how many seats are currently occupied or how many are still available. A Java list handles exactly these kinds of dynamic, ordered scenarios, keeping track of those seats and letting you manipulate the data easily.
It really is eye-opening when you start seeing it like that, how these, well, seemingly basic actions really underpin so much of the software and technology we use every single day, isn't it?
Absolutely. And that's why learning about lists in Java is such a fantastic step towards, well, towards mastering programming in general. They genuinely are one of the more accessible parts of that whole Java collections framework we mentioned, easier to grasp initially than, say, sets or maps, perhaps. And they are used in almost every kind of Java program you can imagine. So you're building a really strong, practical foundation by understanding them.
Definitely. And as we look through the sources you shared, there were some really helpful tips for beginners that jumped out. First, really try to focus on the concept. Just keep that core idea in mind. Storing items in order like a digital queue or a line, don't get too bogged down in the code details immediately. Second, keep using those analogies. Relate lists back to real-world things. The playlist, the line of people, the grocery list. It just makes the abstract concept much more concrete and easier to remember. Third, start small. When or if you decide to actually try writing some code, don't try to build Rome in a day. Experiment with really simple lists first. Maybe make a list of your favorite books or track your top 3 chores for the day. Fourth, ask for help. Seriously, if you get stuck or confused, which happens to everyone, don't just stare at the screen. Check out programming forums, maybe ask a question on a platform like X. The coding community is generally very helpful. And finally, practice patience. Learning programming, even fundamental concepts like lists, takes time. There are different types of lists, lots of methods. It's okay to learn it step by step. I remember when I was first learning that whole forgetting order matters thing. That got me quite a few times. You think you've got it sorted, and suddenly your data's all jumbled.
Oh, yes, that's practically a rite of passage. And speaking of potential pitfalls, here are a few common mistakes to avoid that we noticed highlighted. One is indeed forgetting order. Always remember, lists maintain the sequence you give them unless you explicitly change it. So be intentional about where you add or insert things. Another big one is ignoring indices, especially that starting at 0 thing. Double check your index numbers when you're accessing or modifying items. Those off by one errors are incredibly common when you start out. And lastly, try not to overcomplicate things early on. Stick to the basic operations, adding, removing, getting items until you feel really comfortable. Then you can gradually explore the more advanced features or different types of lists. Don't try to use every single method right away.
That's solid advice. So, okay, now that you've hopefully got a good grasp of these fundamentals, what does this all mean for your next steps? If someone's listened to this and is thinking, right, I get it, what now? Where do they go from here?
Good question. For next steps, based on typical learning paths, we'd suggest a few things. First, maybe learn specific list types. Once you understand the general concept of a list, you can explore the different implementations Java offers, like ArrayList or LinkedList. They have different performance characteristics. Some are faster for adding items, others are faster for accessing items by index. Knowing when to use which is a powerful next step. Second, try coding. Honestly, there's no substitute for actually doing it. Write some simple programs. Create a list. Add items to it. Remove some. Print them out. Maybe make that daily task tracker we talked about, or a simple inventory manager. Third, maybe explore real projects. If you're feeling adventurous, look at some open source Java code online. See how experienced developers use lists in real applications, maybe in games, web applications, or data processing tools. It can be very insightful. And finally, read more. There are tons of great resources. Check out Oracle's official Java tutorials online. They're quite good. Or look into well-regarded beginner books like Head First Java, which uses a very visual, engaging style.
Excellent pointers. And just to hammer home how fundamental and relatable this concept is, let's use one last vivid example. Think about a school's attendance sheet. The teacher probably lists the students' names, often in alphabetical order or maybe the order they sit in. That's an ordered list. They can add a new student's name as someone joins the class midterm. They might remove or mark a student as absent for the day. They can quickly access the list to check the name in the third row, maybe. They might need to update a name if it was initially misspelled, and they can easily count how many students are present or absent just by looking at the list. A Java list could perfectly model and manage this entire attendance process electronically.
That's a perfect closing example. It really does illustrate how foundational lists are, underpinning processes we see everywhere, even completely outside of coding itself. It's a great way to solidify the core idea for you.
And, well, there you have it. That wraps up our deep dive for today. We've covered what lists are in Java, why they're so important for managing ordered data, how they work under the hood with those clever indices starting at 0.
Don't forget the 0.
Never forget the 0. And we looked at the common operations you can perform. It's really clear they're a true cornerstone of programming in Java.
Definitely. And we really hope that using all those analogies throughout, the to-do list, the music playlist, the school lockers, the concert line, grocery list, movie seats, and that final attendance sheet, we hope those help to make what can seem like an abstract programming concept feel much more concrete and, frankly, understandable for you.
So here's a final thought to leave you two on. Now that you understand how something as simple as an ordered list can be so powerful in software, what other systems or processes in your everyday life can you spot that are essentially lists operating under the surface? And how might understanding their indexed access or their dynamic size maybe change how you think about how those systems actually work?
And of course, if your curiosity has been piqued and you want to dive deeper into the actual coding or explore those different list types we mentioned, we absolutely encourage you to follow up on those next steps. The world of programming is vast, but understanding lists is a truly significant first stride.
Absolutely. Well, thank you so much for joining us on this deep dive into Java lists. We'll be back again soon to tackle another complex topic and hopefully make it clear. Until then, keep exploring.